releases heat energy. So that number should be the sum of these two numbers. And the precision, we've got to follow our precision rules to get to the amount of digits that we display in our answer. Check it out, we're almost done. We've got everything we need to find our final solution. The end of our tunnel is what's the C of the metal. That's all we got left here. So let's figure that out. We can go back to this equation. Which one was it? This one. Well, we're going to have to do the little algebra to change it around because we're not looking for Q anymore. We're looking for C. So let's erase this, give ourselves some room. And our C, well, let's do a little algebra. Q equals M times C times change of temperature. Well, we want C, so let's pull out M and change of temperature. Let's take those out. And remember, when we do algebra, we have to do the same on both sides to keep it equal. Whatever we do on one side has to happen on the other. So now we've created a scenario where we can go take out our equivalents. M over M equals 1, so we can pretend it doesn't exist. Change of temperature over change of temperature is 1, so that doesn't exist. We're left with C. C equals Q over M times change of temperature. So let's put that up here. C equals, get that out of the way. Q, we're just switching it around, but it still should be equal. We can do that in algebra. C equals Q over mass times change of temperature. And let's erase this, because we're going to use that to guide our final equation for this problem. And now I've made a mess. So let's keep it clear. Mass times change of temperature. Okay, is that readable? Hopefully it is. Okay, now all we got left is plugging in these digits. Okay, so the C is the Q over the M times change of temperature. What is the Q? The Q of the object is minus 7610 joules. Okay. What is the mass? The mass is right there. Mass of the object. That's what we're looking for. It's 250.0 grams. 250.0 grams. Finally getting to use that. And what is the change of temperature? Boom, right there. So it's these three that we're looking for to find our ultimate objective. So times change of temperature, that's right there, minus 75.4 degrees Celsius. Do we have all our units? Joules, grams, degrees Celsius. Yes. Now, what do we know about negatives and positives? In algebra, we can take out a little bit of clutter by doing this. Well, we know that a positive times a negative is always a negative. Positive times a negative is always a negative. So once we calculate this out, we're going to have a negative. Negative divided by a negative is a positive. So can you see how we can get rid of these? We can get rid of that, get rid of that. We can clean up the negative, take that out, and take that out. And now we have a slightly more simple equation to deal with. But if you're not convinced, let's just keep them there. I don't want to puzzle you, because we can still keep them there and plug them into our calculator as a negative. We just have a little bit more busyness to do, but at least to keep our head straight. Okay, so let's do that. First I'm going to solve for the bottom part. So we've got our final answer is going to be an answer for C, and it's going to include all three of these figures. So let's just put that over here to remind ourselves to make sure our units are in place. Joules over grams times degrees Celsius. Okay, now we can just deal with the numbers. 250.0 times negative 75.4. Okay, let's clear that out. 250.0 times 75.4, and I'm going to turn that into a negative. I can do that at the end of the problem. Now it says 75.4. a negative 75.4. I'll hit the equal sign, and we've got 18,850. How precise are we going to be? This is a multiplication. We're going to use significant figures. We've got 4 here, 3 here. We're going to use 3 significant figures. So that's going to be the bottom of our equation. So 3 significant figures. It's going to be minus 1, 8, and we would say 8, but that 5 rounds the 8 up to a 9. And I've got Maddie wanting to ask me a question right behind me. Yes? You want to leave the room? You tired of listening to me? Okay, go ahead. All right, Maddie's going to leave the room. Okay, don't mind her. Okay, so we got 18,900. That's as specific as we can be using our rules of significant figures. Whoa, you can stay there. Okay, so what are we going to do at the top? Well, we don't have to do anything. We're just going to put minus 7610, and the joules we've already put over here. So let's do that. Clear it out. 7610. We'll make that into a negative, divided by 18900. There. Make that a negative. And guess what? We have a positive answer. And the positive answer is 0.4. How many significant figures? 1, 2, 3. Significant figures. 1, 2, 3 significant figures. So we got 1 significant figure. 0, 2. But the next digit would be 6. We've got 3 significant figures already, so we can't put any more. So what we're going to do, since the next number is a 6, we're going to round that up to a 3 joules over grams times degrees Celsius. Okay, so our answer. This deserves a new color, right? So our answer, let's make it red. Make it exciting. Our answer is 0.403 joules over grams times degrees Celsius. Okay. Now, we might know what kind of metal this is by doing this. If we look at page 50 in your book, that shows you a table. And I'm just curious. 0.40, no, that's not one of these. Okay, I thought it'd be either copper or iron, but it doesn't look like it is. That's our answer for the equation. I'm going to have to double check that to make sure I'm right. And if I'm wrong, we'll see if we can fix my mistake. But that's how you do it. Appreciate your feedback. Any pointers on how to make this clearer, more simple, or